Welcome student of class 10. Last class we studied about the some portion of the refraction. Now we study the refraction of the spherical lens. Spherical lens which are coming from the two sphere. Suppose here it is a one sphere and another sphere here. Two sphere. In middle portion we can cutting it. It is one type of the lens. This portion is known as our, this portion means this portion is known as our convex lens. And here another two sphere, it is a one sphere and another the sphere. And we cut this, means this portion, this much portion is known as our another lens is known as the concave lens. How can we mark the concave and convex lens? In the convex lens, middle portion is the thicker as compared to the side portion must be thinner. And in concave lens, middle portion be thinner and side portion be thicker. Okay? So in this case, when our lens have the two types we can be study. One is the convex lens and another is the concave lens. So in convex lens, middle portion is thick and side portion are the thin. But in the concave lens, middle portion is the thin and side portion are the thicker. Then what happens when the light passes through these two lenses? Here, again also, in this convex lens, this portion is coming from one sphere and this portion coming from the another sphere. So this sphere has the center and it is also a center of the first sphere. Center is the C1, here is the center C2. Now line joining these two center is known as the principal of axis for that lens. And when we draw this imaginary line, when the middle place of the intersecting the principal of axis and this line is known as the optic center, which are known as the mirror is the pole of the mirror. But here we know this is the optic center. From this diameter of the lens also we know the aperture, which are looking also mirror also, that is known as the aperture. Now from this point to this center is the radius of the sphere, so it is also known as the radius of curvature. And this from this point to this also radius of curvature. From same things in concave lens also same thing. This portion coming from one sphere and this portion coming from one sphere. So it is the center of curvature C1 and it is also center C2. This line joining these two centers is the principal of axis. And if we draw the middle line which intersect is known as the optic center for concave lens. Okay. Now we look at what happens when light passes through these two lenses. When it is we take the convex lens. Now it is our principal of axis. It is our optic center. When light pass to our convex lens, after the refraction or refraction, it can be passes through a single point, that is known our focus point. After the refraction, light can be come to converge and meet in a point that is known as our focus point. But in the concave lens, if we take when the light passes parallel to the principal of axis after the reflection of our concave lens, it can diverge each other. Look like that light can coming from the backside of the single point, that is known as the focus point. So this point is the focus point of virtual image, and in this case we get the real image of the object. Okay? So every moment convex lens we get the real image and in concave lens we get the virtual image. Okay? Now, how we can be image formed in the lens? Now we some rule like that we study in the mirror also some rule. That type of some rule here. Suppose this our convex lens, when light is come to the parallel with the principal of axis, after the refraction it can passes through the focus. After the refraction it passes through the focus when the light parallel to the principal of axis is the first rule. In second rule, when the light suppose passes through the focus, that can after refraction is parallel to the principal of axis. And third rule, in the convex lens, when the light passes through the optic of center, it can never change their direction, it can directly pass. And that type 3 rule are can also applicable in the concave lens also. First rule, when the light passes parallel to the principal of axis, it goes through the focus. Another light passes through the focus, after the refraction it goes parallel to the principal axis. Another, when the light passes through the optic center, it never changes that direction, that same direction it can be passed. Okay? Now, we get the different place of the image, how it can be formed in the convex lens. Here, suppose when the object is infinitive distance, when object is infinitive distance, we take the convex lens. Here is the focus point, this is also focus. When the light, we take at least 2 rays, when the light object is at the infinitive distance, 2 rays can be taken. After the refraction, it can be passes through the focus. So, the image of the object at f, point size, real and inverted. Okay? Then when the object is beyond C, before center of curvature, here you take the focus, center of curvature, focus is the F1, C1 is the F2, C2. This time here also F1, sorry, is the F2, F1. Now object is AB beyond the center of curvature. Now we take one ray parallel with the principal of axis. After the refraction, it passes through the focus. And another ray we take through the focus. After it can parallel to the principal axis. Where these 2 rays are meet, they are the image of the object ADS BDS formed in between the focus and center of curvature. The size is small, inverted and real. Okay? Then when the object at C, now is the focus 1, center of curvature, focus 2, center of curvature. Second, when object is at F, object AB. Now one ray passes parallel to principal axis. After it can passes through the focus. Then another ray through the focus. After refraction, it can parallel to the principal axis. And where it can meet? It meet at the center of curvature, where our image of the object form, that is ADS BDS. The size of the image must be equal in object size. Okay? And this is the inverted and the real. This type, when we take a object in between center of curvature and focus, this type. Another, when object at the between C1 and F1, center of curvature and focus. Now here is our lens, here is our focus, is the center of curvature, here is the focus, is the center of curvature. In between here object is present AB. The one ray parallel to principal axis, after it can passes through the focus, and another ray which can be through the focus, it can parallel to this. So now the image can be formed after the center of curvature. After the center of curvature, in the center of curvature image A dash B dash is the big size, inverted and real. Okay. Then when the object at F, when the object at F, this type here, when the object at F, now at F, our focus point, center, F2, C2. Object at F, AP object, one ray passes parallel to focus, parallel to principal axis, then it passes through the focus after refraction, and another we take from optic center, it can pass as this. So they never meet. They become the parallel line, but we can remark here the object be large in size, inverted and real. Okay, but when the object is between the optic center and focus, between optic center and F, this is our focus. F1 is the center of curvature, is the F2 is the center of curvature. When object is here AB and light passes, or one ray we take parallel to principal of axis, after it can passes through the focus, and another ray through the optic center. They both rays are far away from each other, such that both rays coming from back side of the lens, and here the image form A dash B dash. This image be the virtual erect and back side of the lens. Okay, this type we can find the different image in the concave lens also. You would take the concave lens. Suppose we take the ray here, focus point, center of curvature is the center of curvature, focus, you will parallel to right is the optic center. After focus it can be, after the refraction it can be diverge, and another ray we can take here parallel to the axis, after it can be diverge. Look like it can coming from the back side, that the F1. This time we can find the virtual image in concave lens, and is the very point size, okay, and back side of the lens. Okay. Now some sign, signification of the sign means which signification of sign do you study in mirror, spherical mirror case, same this also. Okay, and their lens formula is what is? Lens formula 1 by V minus 1 by U equal to 1 by F is our lens formula, and their magnification M equal to H dash by H is equal to V by U. Now some problem here also. What is the problem? Given here problem, a concave lens whose focal length is the 15 cm, concave lens focal length given the 15 cm, f equal to minus 15 cm, and at what distance should be the object from the lens should be placed it from the image 10 cm. So distance of the image v equal to minus 10 cm. Find the position of the object, nature, size and magnification also. Now we can find 1 by v minus 1 by u equal to 1 by f. Now 1 by v minus 1 by f equal to 1 by u. So 1 by u equal to 1 by minus 10 minus 1 by minus 15. So 1 by u equal to 1 by minus 10 plus 1 by 15. So 1 by u equal to LCM we take the 30 minus 3 plus 2. So 1 by u equal to minus 1 by 30. So u equal to minus 30. So object must be placed from the lens 30 cm from the lens. Okay. Then there you will find the magnification as 30 cm. Magnification m equal to h dash by h is nothing here, height of the object. So here given only v by u. V is the minus 10 by minus 30 equal to 1 by 3. So image the very small in size due to here the 3 parts to find the 1 parts. Okay. Then another problem is the here